Hello, everyone, and thank you for joining us today. I'd like to introduce myself. I'm Lisa Sturgles. I'm the Marketing Programs and Events Specialist at McCrometer, and I'll be your moderator today. We have people joining us from around the world, so we're just going to take 1 minute so that we can make sure everyone's joining us. And during that time, let me do a little bit of housekeeping for you. We'd like to invite you to take control of your audience console. Use the controls to minimize or maximize each box to personalize your webinar experience. To resize a box, drag the bottom right-hand corner. If you have a question, please click the Q&A icon at the bottom of your screen or use the open Q&A box on the right-hand side of your console. Click the documents in the resource area to download them. We also have live links in our resource area. One takes you to our blog, and we invite you to sign up for that for more information. And also, one will take you to our YouTube channel, where we have a new VCone working demo video that we'd love for you to see. So it is my pleasure now to introduce our speaker for today, Alex Barker.
My name is Alex Barker. I'm the Applications Engineering Manager at McCrometer. I run a team of engineers who work with the VCone flow meter, which we're going to be talking about today. Just a quick review of my background. I have my Bachelor's of Science in Mechanical Engineering from the University of California, Riverside, and then I'm currently finishing up a master's program in Systems Architecture and Engineering from the University of Southern California. So today, we're going to take a little bit of a broad view on the principles of the VCone flow meter. We're going to be taking a look at some of the basic background of DP measurement, as well as a little bit of a comparison and contrast between different types of flow meters, the applications that you would find them in, as well as some of the more characteristics of the meters themselves. So let's go ahead and get started. So first, I want to just kind of draw everybody into a little bit of the very bare bones basics. So if any of you are engineers in the audience, perhaps you have heard of Daniel Bernoulli. His principal equation is the Bernoulli equation, as I've shown to the right, with the variables so defined below that. And really what we're going to get from this equation is that in a closed pipe running full, there's an inverse relationship between pressure and velocity. And this really forms the foundation of DP flow. So taking a look inside the meter itself, at a basic level, a VCone is essentially a conical obstruction that's placed in the center of a pipe with a high pressure port and a low pressure port, with flow running in the direction as indicated. What we're going to be doing is taking a difference in measurement between that high pressure and the low pressure. As we learned previously, that inverse relationship means that as the flow moves across the obstruction over a smaller amount of surface area, there's going to be an increase in velocity, which leads from an inverse relationship to a lower pressure at the end of the obstruction. One of the principal components of the VCone is the beta ratio. This is the ratio between the outside diameter of the cone and the inside diameter of the header pipe. Most specifically, that beta ratio, as you notice, because it's a kind of a variable outer diameter of the cone, we're specifically focused on what we call the beta edge. That's the very largest outside diameter of the cone. So taking the beta ratio as well as a number of other flow constants, we get to the VCone flow equations. These are derived from Bernoulli's theorem at its basic level through a number of different pieces of math. However, I'm not going to go too much into that today. We do have much more information available on that online in the IOM manual, which you'll see in the resource section, as well as a number of other documents that can be found on our partnership portal website. The flow constants here noted are K1 and K, and they relate to the cone's beta ratio and volumetric profile. Now you note we have two separate equations here, one for gas and one for liquid. Slight differences in between the two just to make sure to correct, particularly for the gas expansion factor in the gas equation. Finally, one of the most important aspects is the flow meter's coefficient, or CF, as noted in the equations to the left. It's a geometric correction factor we obtain through calibration. So once we take everything together, we get the VCone meter. Just a little background on the product line. McCrometer owned the original patent starting in 1985 to bring our customers in the industrial, municipal, and oil and gas industries a highly accurate and repeatable flow measurement. This highly customizable product is engineered to withstand high temperatures and the pressures from the Earth's surface to the bottom of the ocean and is deployed on 6 of the world's 7 continents. Some of the basic attributes of that meter itself: high accuracy and repeatability. When calibrated over the full Reynolds number range, we can achieve an accuracy of plus or minus 0.5%. And when we calibrate over a partial range with an extrapolation, we can even get to the still 1% meter. High turn down rates are one of the key components here. Standard, every meter we size for a 10-to-1 turn down rate. However, I've been able to find certain meters, depending on the process conditions, of course, that we can even go up to 50-to-1 turn down, and getting that either the 1% accuracy with the extrapolation or 0.5% when calibrated over the full range. Additionally, the VCone is a 25-plus year lifespan, so virtually all maintenance and need for replacement is eliminated over that time span, much longer than a lot of competing meters. The VCone is very much optimized for constrained spaces, meaning that there are very low straight run requirements in order to keep the meter functioning. You'll notice the two different charts below here. One is a range of gases and liquids, depending on where they are. But the real important part that I want to show everybody here is that look at the differences in the upstream and the downstream. 1 diameters, maybe 2 diameters on a couple of options. But in a lot of cases for downstream, you're looking at 0 diameters. The only one that we have a little bit of concern with is if it's placed directly downstream of a control valve. Shut-off valves, we don't have the same problem with it, but the sort of partially open gates on the valves can create some problems for a number of different flow measurement devices. The VCone can be created in a number of large line sizes. And now what we had found, and a sort of a new novel design that we've been working on lately, has been additional support for our large line sizes, specifically looking in the 18-inch and larger range. We've added a triple gusset design that counteracts the effects of the low resonant frequencies, meaning that for larger meters, the frequency can be low and cause the cone inside to vibrate. Now, in order to stop that from happening, we've added this design over here, which adds an additional amount of bracing and support to counteract the effects of vibration. Now I'm going to take a look a little bit at some of the additional other technologies in the DP field that are very similar to the VCone. The first and most obvious is going to be the orifice plate. So the real key component and difference here is that the VCone does not have any need for a lot of straight run. 0 to 3 diameters in the maximum, whereas orifice plates, you're going to be looking at somewhere between 40 diameters upstream and 20 diameters downstream. So significant amounts of straight run required. Compared to the orifice plate, the VCone is a premium product. It's got a 25-year lifespan to it. Whereas the orifice plate, it's a small utilization of material and it's inexpensive. But you're trading with that inexpensiveness the need for frequent maintenance. Turn down ranges, again, VCone 10-to-1, as we had discussed a little bit earlier, whereas orifice plates, typically you're going to be looking at a range of 4-to-1. Finally, calibration. The VCone can be calibrated up to an accuracy of 0.5%. However, with the orifice plates, you would typically be looking at it to remain uncalibrated. Next, let's take a look at the Venturi meter. So kind of a similar DP concept. The VCone, I kind of like to say, is sometimes like it's an inside-out Venturi, whereas the choke point in the Venturi is built into the ID of the pipe. We make that choke point suspended as an obstruction in the center of the pipe. Straight run-wise, the VCone, again, 0 to 3 diameters, as we've been talking about. The Venturi does require a bit more, somewhere between 5 and 20 diameters on all applications. We do note with the Venturi that when you have small line sizes where straight run's not an issue, you can find a little bit more cost-effective with the Venturi. However, for sure, anything over 16-inch diameter, the VCone is going to be your better option. You don't need that really thick center header pipe, which is going to cause immense weight issues, where the VCone, you can still go with larger line sizes while still using a schedule standard pipe. When calibrated to ISO 51675, the VCone can achieve an accuracy of 0.5%, whereas when calibrated to the same ISO standard, the Venturi would be looking to achieve an accuracy somewhere between 0.7% and 1.0%. Finally, standard turndown ranges. We again spoke about the VCone as being 10 to 1, whereas the standard for the Venturi is 4 to 1. Lastly, let's take a look at the Coriolis meter. So the Coriolis meter is a moving parts meter with limited material customization based on those moving parts. VCone, on the other hand, has no moving parts. This is a solid welded piece of material in there. The Coriolis will, however, give a higher accuracy than the VCone. 0.1% to 0.15%. Now this is due to it being not necessarily a DP meter, but it's a direct mass measurement. The VCone, of course, up to 0.5%. Where the VCone does kind of work against the Coriolis, however, turndown ranges. Coriolis averages out around 5 to 1, whereas the VCone looking at 10 to 1. And our 25-plus year lifespan with virtually no maintenance contrasted to the Coriolis recalibration and testing on an annual basis, as well as the issue of any of those moving parts getting corroded away would cause a need for immediate replacement. And then generally for Coriolises, you're going to be looking at them in sizes less than 10 inches, whereas the VCone has a broad sizability range all the way from 0.5 inches at our smaller end to 120 inches in the larger end. Now that we've done a little comparison and contrast, I'd like to talk a little bit about applications and sort of where you would use the VCone and why you would choose the VCone for a specific application. I'd like to start with the FPSO, or a floating production, storage, and offloading vessel. It's a ship that goes to sea that helps deliver and refine petroleum products as they're in transit to an offloading place on land. Now, obviously, given you have a ship, the size constraints of a ship, the straight run optimization on the VCone makes it an incredible option for these vessels. Again, with high accuracy and repeatability, they're general standards of the oil and gas industry. So you're going to need it regardless. And the broad turndown range allows for greater flexibility in confined spaces, which a ship is very much a confined space. Finally, the 25-year VCone life expectancy limits the need for operations downtime, at least due to the VCone itself. Second, I'd like to take a look at the industrial steam applications. Steam is a fairly broad category. It can include power plants, university and business campuses, and just general HVAC and heating requirements. Requires a lot of accuracy and repeatability. We want to ensure that energy is not wasted, particularly as we look to diversifying and creating a more green economy. Accuracy and reliability are crucial to ensure that energy is not wasted. The VCone typically reduces the plant real estate needs, piping material associated pipe support structure, installation labor by 50% or more. So really, to help kind of keep the real estate down, you'd be looking at the VCone as a really good feature in the steam market. Process separators. These are when you're taking in fluids that are combined with a number of different items in it. It could have some solids, some liquids, some gases. These separators are able to remove the individual components, and given the limited straight run need, they can be placed very close to elbows, keeping them close to the actual separator itself and still getting an accurate measurement. and it can ensure that any process formulas, because of that accuracy, are going to be consistent in their outputs. VCone's adaptability to wet gas scenarios as well allows it to control the measurement from the input side. And obviously this process conditions depending, whether it's an actual wet gas application or if we would call it a multi-phase, which the VCone is not for multi-phase. Liquid natural gas, which is a cryogenic form of natural gas that's used for bulk storage and transport. The VCone actually has a fair number of experience working in it. With our custom material options to be able to work under high pressure and cryogenic conditions, it makes for a very versatile meter in this field. And with no moving parts, it's very preferable within the LNG industry. And just based on standards of liquid natural gas, you'd be looking at large budgets to be able to spend. Therefore, with the customization of materials and the customization of the meter, it makes it a good option for expenditures in metering packages. Subsea, or literally, as we would say, meters that are placed on the bottom of the ocean. So these are for oil and gas and drilling operations where you're extracting the meter and you want to keep a lot of the actual infrastructure near the bottom of the ocean. Obviously, you're not going to be laying individual pipes. You'd be putting larger skids, some of these applications down on the bottom of the ocean. And so straight run is going to be one of the primary components here so that you're not having to try to install a large skid on the bottom of the ocean. And the VCone is perfect there. With our 0 to 3 diameter straight run, you can save costs with buying and installing subsea piping. The high accuracy and repeatability are standards of the oil and gas industry, in particular for something that would be very expensive to perform maintenance on. 25+ year lifespan is going to be crucial here. It's not like you can just go dive down and go fix this thing. You know, it's pretty much there to stay once you put the skid on the bottom of the ocean. Enhanced oil recovery, the process of being able to use CO2 to extract additional hydrocarbons from the ground. We have a long history of using CO2, including supercritical CO2, with the VCone in the past. It's a pretty standard option for in the offshore enhanced oil recovery. When needing low straight run when operating on platforms, obviously, you're very limited in the amount of real estate that you have on those large platforms. And in custom materials, increase the adaptability and reliability in high pressure applications and in the ability with dealing with things such as sour gas, where material choice is really going to be a crucial deciding factor. McCrometer does work very well within the wet gas market. We can achieve wet gas corrections of plus or minus 2% accuracy. Obviously, the big kind of caveat with wet gas is depending on process conditions and whether or not things actually are wet gases versus multi-phase. The VCone was tested to be most accurate side-by-side comparison with other DP measurement technologies. And there's virtually no need for maintenance, and it practically eliminates downtime due to the VCone itself. We do, however, operate outside of the oil and gas industry. Specifically, we have some decent applications we can work within the municipal water treatment area. VCone straight runs for optimization, adaptability, and legacy plants, and limiting real estate costs needed for new plants. So, you know, even older water treatment plants might not have the real estate available for large amounts of straight run, particularly if they were built in areas that may have at the time been a little bit more rural, but now find themselves being slightly more urban. And then obviously if you're trying to build new water treatment plants, which is necessary with growing populations, you want to be able to limit real estate costs, keeps the total cost of the plant down. And so keeping those straight run requirements to a minimum, we're able to help out with that on the VCone. We can do accurate readings in turbulent areas near disturbers. And then additionally, the cone itself acts as a little bit of a flow straightener. We want to avoid applications where there's large amounts of solids present, just simply because of the way that the pressure ports are done. Solids have a tendency to clog things up. So we want to stay away from any solid effluent applications within the water treatment plants. Another part of water treatment plants you might be working with is digester gas. Now here the material customization to help limiting the corrosive elements within digester gas. There can be a lot of nasty stuff within it, so we want to make sure that we have a meter that lasts for a long time, as we've mentioned a number of times, but that also is going to be working and not corroding. Metering is crucial to ensure that customers are complying with state, federal, environmental regulations. Some of this stuff is kind of shot off as flare gas, as you can see. I've seen driving down the road a couple of times, and so ensuring that you're putting in an effective amount of gas out to the atmosphere can be important. And finally, we have a pretty wide variability of beta ratios that helps to limit head loss. Particularly, we've seen digester gas applications be very low pressure. So, if your head loss is taking up 50% of the actual pressure you have available, the VCone works very well to help limit that. So now that we've talked a little bit about applications, I'd like to go a little bit more in depth on sort of the standard product offerings that we have available for the VCone and the other customization as well. But we'll want to start with some of the standard offerings. So we maintain a variety of pre-configured model numbers via standard part number system. One of the examples I've kind of shown over here to the left is for low pressure ANSI class 150 and 300 weld neck flanges. For these standard offerings, we try to keep the variability limited so that we can be able to produce them a little bit faster. And when you're looking at a lot of the standard product offerings, you're looking at between 4 and 8 week delivery. Now, I need to put the caveat of 8 weeks on this one over here because of that 24-inch and a couple of the larger ones at the bottom. However, when you're moving in the standard sizes, we generally find within the 4 to 8-inch range, those can be completed usually in 4 weeks. And then with the number of other options we'll go over in a second. Now, on the custom side, this is when we get to a lot of the really fun stuff. So there is a huge availability of custom offerings that McCrometer can offer to all of our customers. So we have a proven track record of fabricating meters up to a 78-inch line size, literally VCones that you're able to walk through if there wouldn't be a cone in the center of it. And then we can even go larger than 78, depending upon the customer's request. We also can add custom wall thicknesses. If you have really high pressure applications, I've seen things that are over an inch thick, over an inch and a half thick even, as well as adding in reducers. We've done regular reducers. We've seen eccentric reducers. All of that is going to be available upon request. There are a number of different end connections that we have, high variability there. I kind of mentioned on the initial slide about the low pressure weld neck flanges. Well, if you take a look, those are just 2 options within a broad list. Here we have at least 52 that are named in our current part number system. Some of the most common ones here, obviously slip-on and weld neck ANSI flanges. We have options for plain and beveled end, threaded end. You see here we have like DIN flanges. We can do API 10K flanges. So a real huge variability. Really kind of depends upon whatever the customer wants, as well as additional end connections available upon request. We don't have a necessary option for the different types of hubs we can offer, but if there's a specific hub that you would like, we can approach different manufacturers and get that information. So the part of measurement, the real time of measurement here for the customer is going to be the DP tap. These are the high pressure port and the low pressure port. Now, the original drawing I showed you was just kind of how we normally do it, but there is a lot of different options that we can offer you here as well. So I kind of just posted 3 up here to show you the difference. The first farthest to the left, flangelettes. Fairly standard to see a lot of customers ask for that. So it's just, the tap, but with the flange end connections there. Then the second 2 pictures, we're going to go into some of the little more wild options that we can offer. We've seen in the past that we can do multiple sets of taps, as seen over here. There's 3 sets of taps on this meter where the customer also wanted a pipe nipple to be coming off of it. And then it might be a little difficult to see, but there's also 3 separate ports for RTD on the right side of the center meter picture. But those RTD ports are also offset by a certain angle. I think it's off by like 15 to 45 degrees, 15 degrees or something like that in there. So there's a high amount of customization that our team can offer. Finally, the last picture, it might be a little difficult to see, but the tap connection there actually has a valve tree with 3 different valves that are put on it. Again, specified by the customer. If you want the meter to be sold with the valves to be on it, we are happy to oblige. I'd mentioned in a couple of the applications the number of different material options we have. So the VCone team has a wide experience in a wide range of materials. And we can even special order materials that meet customer specification beyond just the standard ASTM and whatever's in that. We have an adaptable process to certify welders on exotic materials for the customer as needed. Just taking a look to the chart to the left, a couple of different options. We have this most standard carbon and stainless steels, but then also we can take a look at things like duplexes and super duplexes, Inconel 625 and Incalloy, Hastalloy, and even some of the newer stuff we've seen, titanium requests, and pretty much everything in between. And just as a quick note, McCrometer, we're more than happy to suggest materials that could work for the customer's application, but at the end of the day, it is your responsibility to choose. You know your process better than we ever could, and we're happy to work with you. We have a great engineering team that'd be happy to do so. So I just wanted to put everything together as to kind of what we can do over here. I wanted to just kind of point out the picture to the right here. This is it's a 1/2-inch meter, so tiny little meter, and it has the cone suspended in the middle, just the same as the pictures we've seen, that large 78-inch meter. But it's also been meant to include a 1-inch RTD, so an RTD that's twice the size of the pipe it's attached to, as well as 1/2-inch DP taps, which are the same size as the pipe it's attached to. I mean, the amount of customization there was key and crucial with some amazing welding capabilities we have in our shop to be able to produce a really interesting looking meter, I think is the best word to go about it. Beyond the specifications of the meter themselves, we have a number of offering in-house calibrations at McCrometer's NIST traceable labs, flow labs, that are certified to NavLab, which is ISO 17025. We have 2 facilities that are located at McCrometer itself, one in Hemet, California that goes from 1/2-inch to 14-inch, and one in Porterville from 16-inch to 72-inch. So all McCrometer VCones are calibrated as part of the standard process that we partake in. If you need those high accuracy services and our water lab is not going to be enough to get that accuracy that you need, we do offer a number of third-party calibration services in the fluids such as air, gas, oil, as well as large line size water calibrations for some of the things if you want the higher than 72-inch line size. And this is to achieve the maximum accuracy in order to recalibrate over the full Reynolds number range. McCrometer also offers a large array of non-destructive testing for meters with a number of standards such as X-ray, dye penetrant, and hydrostatic test, which are very commonly requested, all the way to more custom tests, positive material identifications, NACE hardness tests, which is a crucial component to comply to NACE MRO 175 for the oil and gas industry. Also ultrasonic inspection, magnetic particle testing, and visual inspection as requested. When you talk about building just the meter, you have kind of just a metallic looking object. A lot of customers, when they install it in their line, want to have whatever the VCone is to match the coating and paints that the rest of their pipe line may be. So McCrometer has a couple of standard options that are readily available, from the blue that you would see on the picture to the left, as well as things like our high temperature silver, or if you're not looking to have it coated, we do offer a standard rust inhibitor. If you do have something a little bit more custom and you would like to do, say, the green meter on the right, we have the ability to review paint specifications. Just all we need is the system and the color of the paint that you want, and then we can find a way to get it painted according to your specifications. Additionally, for certain applications, you may choose to go with cladding or a weld overlay on the ID of the meter to ensure that all wetted parts are a certain material, even though the whole body of the meter doesn't have to be. One particular example with this would be for a little bit more corrosive and sour gas applications, where you may not want to make a large, I don't know, say 16 or 18-inch meter out of a full Inconel 825. The cladding option allows you to use, per se, a low-temp carbon steel body, and then a cladding on the inside of Inconel 825, Incaloy, sorry, 825, in order to ensure that all wetted parts stay the same. The VCone complies to a number of global standards. Our McCrometer's manufacturing facilities are all certified to ISO 9001, and as mentioned before, both calibration facilities certified to ISO 17025 or NAVLAP. For European customers, the VCone can meet the specifications, and we can provide all the necessary documentation for the Pressure Equipment Directive or PED certification. Finally, we have a very specialized team of engineers that are able to distill, interpret, and engineer custom requirements and provide specifications in the most challenging applications. So this is where we talked before a little bit about some of the custom options that McCrometer can offer. We have a very specialized team who's really able to kind of work with it. All we need are just, the major project documentations. We'll review it. We'll pull out the requirements as needed, and we'll be able to quote you any options that you may require. So now that we've gone over all the different aspects of the meter, how do you know what you need in order to start asking more questions about a specific application or order one? So upon request on an email I'll provide to you on the next slide, we have a quote information form available to be able to help you gather all the relevant information to configure it. And once we're able to gather that information, we'll be able to not only provide you quotes on the meters that you're looking for, we can provide initial sizing calculations, and then for some of the larger projects, we can even provide an array of different documentation options depending on whatever VDRL, vendor document requirement list, might have. So if you would like to learn more and are interested in learning about the VCone or learning about McCrometer, you can always feel free to visit our website at McCrometer.com. Or each of the areas around the globe has a McCrometer regional sales manager. We'll be able to help you get in touch with either a channel partner or working directly with us on occasion. The best thing to get started, if you have a data sheet and you're ready to go, send us an email at vconerfq@mccrometer.com. And our team of specialized engineers will be happy to give you a quote. Now I'll turn it back over to Lisa for a second here to help finish us off.
Thank you, Alex. Great presentation. Appreciate all of your valuable information. And we'd like to thank all of our viewers for joining us today. We'll now answer your questions submitted during the webinar. We do have a few of those for you, Alex. But just a note to everyone on the call or everyone watching later on demand, to receive information regularly from us, I just want to remind you again to sign up at our blog at mccrometer.com/blog, or click on the link in the resource box on your screen to the right. Or you can go to our YouTube channel at youtube.com/mccrometer to view our latest video and subscribe to always be updated when we post a new video. And let me get to our Q&A for you, Alex. We do have a few questions. The first one is, what is a Reynolds range number?
That's a pretty good question, Lisa. So a little bit more, going back to some of the core principles of DP and flow. So Reynolds number is a non-unit based number that talks about the velocity and the flow of fluid through a pipe. Essentially, it's related to a combination of viscosity, velocity, and the density of that fluid. And it really just kind of characterizes how fast the water or whatever fluid is flowing. Specifically why for VCone and flow measurement we're interested in that is the range over which, if we calibrate it, we want to be able to hit those numbers. We've found that not only can you calibrate in a specific fluid over that range, but that you can achieve a highly accurate calibration, say matching Reynolds numbers in a different fluid to whatever fluid that you have. That's the way we are able to use water to calibrate gas applications.
Okay, thank you. The next question is, can you mount a DP transmitter directly on the meter?
So yes, one option I didn't really show off in here, however we do have, is for direct mount, we would call it. We're able to put a direct mount plate on top of the set of taps. So for the various transmitters that are configured for that, we're able to do so. There are a couple of, I think the only areas where you would see trouble there is in very high temperature applications where you don't have ability to cool the fluid down a little bit before you're measuring DP through the impulse lines. So I think the only difference there is going to be whatever the limitations of the transmitter you choose are.
Okay, thank you for that. The next question is, do you offer meters certified in ISO 5167-5?
Yeah, absolutely. So for those of you who may not know, ISO 51675 is an international ISO standard that particularly relates to cone meter technology. So we have a number of options that we can do to approach ISO 51675. Just based on the standard itself, there's a mechanical design option. So we can check if the meter can pass ISO via that. Or the second part of that ISO standard is a calibration over the full Reynolds number range, which we can do. Either we can try to do it in our own facilities, or we can offer third-party calibration. So it's really according to the customer need.
Great, thank you. And the last question I have is, what is the accuracy of the orifice plate technology?
So the accuracy of the orifice plate technology, it is covered in ISO 5167-1, the orifice plate, and similar to a VCone, you can get up to 0.5% accuracy on the orifice plate. Now, I think the big question that people ask, though, about it is, do you really want to calibrate an orifice plate? I noted earlier that, typically orifice plates are sold uncalibrated, that being that the price of calibration can far exceed the cost of the orifice plate itself. So it's really a question of, our VCones, they come fully calibrated as they are. So yes, the orifice plate can achieve a similar accuracy to the VCone, but the question being, do you really want to calibrate an orifice plate? And that's up to, obviously, the customer to decide.
Okay, thank you. And thank you, Alex, again for your presentation today. And thank you, everyone, for joining us. You can always find more information or send us a question by visiting our website at www.McCrometer.com. Thanks again, Alex. Appreciate you being here.
Thanks, Lisa. And thanks, everybody. Happy to be here.